Okay, right. Another letter one. Shopkeeper. We're keeping all of the E's together. So if we keep all of the E's together, treat them as one. So it should be, how many factorial do you think, Pakawa? Okay, so we've got 7 here, and we treat this as 1. Yeah. And then we're dividing it by what, Nasia? Y. 2 p's. And this gives us 160. 20,160. So yeah. All right, now the next one, you find the number of different ways in which the 10 letters of the word shopkeeper can be arranged so that the P's are not next to each other. We're getting good with the strategy. So what's our strategy here, Thomas? Yeah, total ways, subtract P's together. How are we going to get total ways? What do you say for this one, Pazia? 10 factorial because? Yes. And then 3 factorial, 2 factorial because? 3 E's, 2 P's, perfect. And then we're going to subtract P's together. So didn't we actually just do the P's together? Or no, that was something else, wasn't it? Okay, if we keep the P's together, what will we have there, Kenny? Okay, so you can think of the P's as 1, and then that leaves you with another 8 letters, which would be S, H, O, K, E, 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 R. And so altogether there's 9, because you count this as 1 letter here. And then you've got the 3 E's, so you're going to do 3 factorial for that. Now what does this give us in total? Has anyone got that last year? Yeah, good. Now this one's a probability. It says find the probability that a randomly chosen arrangement of 10 letters of the word shopkeeper has an E at the beginning and an E at the end. So we've got total ways already. So we just need to find the ways that we can get an E at the beginning and an E at the end. So it'll be E with 8 gaps. And then E. So we've got to arrange it. This will be 8 factorial. Now, are there any double ups going to be in that area? If we take two of these E's out, 2 P's. And that gives us 20,160. Now, we are trying to actually find probability of this. So we need to divide that by the total number of ways, which we did in the previous question. What was it? It was like, yeah, it was 10 factorial over 3. Yeah, that's looking real messy. Well, was it 10 factorial divided by 3 factorial, 2 factorial? What does that end up being? 302,400. Okay. And screen of death. Oh, good. I thought we were gonna end up losing all of that. Say again. Okay, and just in case that didn't come out on the video, that's the total ways that we got up here. So yeah, it's really not happy about life, is it? So that's that one there. Okay. Is it 150? Oh yes. Okay, cool. And that simplifies to 1/15. Very good. Thank you for that. No. Okay, so next one. 4 letters are selected from the word 10 letters of the word shopkeeper, and we've got to find different selections if the 4 letters include exactly 1 P. Okay. So what you need to think about here, so we're getting rid of one of the P's. Or we're getting rid of both of them because we only have 1 P. But the problem is we've got these extra E's here, don't we? So we can have P and then 3 letters that aren't E. We could have P and 1 E and then 2 letters that aren't E. Or we could have P and 2 letters that are E and 1 letter that's not. Or we could have P. All right. So hopefully, so if we're not dealing with any E's, how many are non-E letters? S-H-O-K-R. Shocker. Okay. So the first one will be 5, choose 3, because there's 5 letters we can choose from there. And I think that's 10. What do you think about the next one, Thomas? It's, also 10. The last one there, next one, Kenny? Yeah, and the last one would be? Yeah, 5, choose none. So, well, one way. Okay, so we add them all together. Now, just when you guys were getting happy and thinking that you knew how to do this, we've got one of these people ones. Okay. Mr. and Mrs. Ahmed with their 2 children and Mr. and Mrs. Baker with their 3 children are visiting an activity centre together. They will divide into groups for some of the activities. In how many ways can the 9 people be divided into a group of 6 and a group of 3? Now, does the order matter here or does it not matter? It doesn't matter. So we're doing choose. So 9 people into a group of 6. So we go 9, choose 6. Okay, so we've chosen a group of 6. And then from the last 3, we go 3, choose all of them, which is 3. And that should give us our total. So what does that give us? 84. That's nice. Isn't too bad, is it? Five of the 9 people are selected at random for a particular activity. Find the probability that this group of 5 people contains all 3 of the Baker children. Okay. Probability. Well, if it contains all of the children, so we've got 3 Baker children, how many people have we got left? 6, and from them we're choosing 2 more. Okay. So this is ways of choosing a group of 5 with Baker children included. Right, so we're just saying we've got them as 3 and we need 2 more people to fill the group. Now, what are the total ways that we can choose the 5? Yes, someone's got it? 9, choose 5. Should have seen Pazia's look at you just a minute ago. She was. Okay, now if we're turning it into probability, Thomas, what could we do? Other way. No, the total way should be at the bottom. So it should be 6, choose 2, over, or divide by 9, choose 5, and that gives us 542. Okay. You always these questions. Next one, they kind of get me wondering. 9 people stand in a line, as you do. Find the number of different arrangements in which Mr. Ahmed is not standing next to Mr. Baker. You kind of wonder what kind of familial relationships are between these two families. Do they not get on and they're forced to do family activities together, or I don't know. Okay, so it's pretty odd. So why don't we do total ways, and then we'll just treat them like we've been treating the letters and put them together. Treat people like letters. Well, it's better than treating them like numbers, isn't it? No, you think not? Okay, so the total ways we can arrange them are 9 factorial. Do we need to divide it by anything? No, because they're not clones, right? Okay. Okay, now what about the ways that they're together? So if we had Mr. A, Mr. B, and they're together, and then we've got the other 1, 2, 3, 4, 5, 6, 7. So that would be 8 factorial. But yes. They are very different. Yeah, yes, exactly. Because we could arrange them, we could have, for each of those arrangements, we could have Mr. A first and then Mr. B, or we could have Mr. B first and Mr. A. So it'd be times 2. Good spotting there. And that gives us a lot. Are we getting 282,240? Great. Yeah, just stop stuffing around. Yes, okay. Find the number of different arrangements in which there's exactly one person between them. Now we're going to try and buffer the relational tension by putting someone between them. So I've got what we'll just instead of whoops, we're going to go A, buffer B. All right. Now, how many different arrangements in which there is one person between them? So I guess we've got to decide on who the person between them is. Lucky them. So that would be, there's 7 people left over, so it's 7 choose 1, 7 options, right? To me. Okay, so that's that. And then after that, we're going to treat them as one group. And then how many other people have we got left? Okay, 1, 2, 3, 4, 5, 6. So to arrange things, it would be 7 factorial, right? Because you've got the 6 people and also that conglomerate group of 3. Okay, and then because Mr. Ahmed and Mr. Baker can be swapped, they could be, you know, Ahmed could be first in Baker, or Baker could be first in Ahmed. So then we're going to times that by 2. What does that give us? I actually didn't end up writing it down on my own paper, so I'll just can I grab that, please? Cool. Are you okay with that or not? Yep. You're right there, Nelsia? Yep. Choice. Okay, right. Last one for the day. Let's see if we can whiz through this. October 53. A committee of 9 people is to be chosen from 9 people. What? For 6 people. I can read. 9 women and 5 men. Okay. Find the number of ways which 6 people can be chosen if there must be more women than sexism, right? More women than men on the committee. Okay, so we could have woman, 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 How many do we have in this committee? 1, 2, 3, 4, 5, 6. Right? We could have all women on the committee. Diversity. Very diverse. Now, we'd just be picking amongst the women. So there's 9 women. So it's 9 choose 6. Okay, that would be 84. Or we could have woman, 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 1, 2, 3, 4, 5, man, 4 guy. Okay, and now how would we represent this one, Thomas? Yeah. Times 5, choose 1. Do you see why? You've chosen the 5 women, but now you've got to select the man. And there's 5 men to select from, so 5 options there. What does that give us there, Nasia? And then we've got this way, what woman, 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 man, man for moral support. And in this case, Canuck. That's 1260. Now, there's no other ways we can do this, because if we add one more man to the mix, that's equal numbers of men and women, which doesn't fit the criteria. So the total is 1974. And now we are told that the 9 women and 5 men include a sister and a brother, and we've got to find the ways that they can be chosen so that the sister and the brother cannot both be on the committee, because presumably they'd fight or something. Okay. So we'll do total ways. That's total ways. And then we're going to find ways bro and sis are on. Okay. So if the dude is on, that leaves, and the woman is on, that leaves you with 12 people to pick from. And if there's 2 already on and you're picking committee of 6, that would be 12 choose 4. Do you see that? You've chosen 2. There's 12 people left to choose from, and you're choosing 4 of them. So that would be 12 choose 4, which is 495. And so if you want to find the number of ways the committee can be arranged that you don't have them on, it's going to be 3003 subtract the 495, which gives us 2508. Okie dokie. The 9 letters in the word reserved are arranged in a random order. Find the probability that the arrangement has a V as the first letter and an E as the last letter. So, first step, who's got an idea? What do we need to do first? Yeah, I heard someone say it. Did you say total? Total ways. Very good. Total ways. Like it. So there are 8 letters. Are there any double ups here that we can see? E's. Oh, wait, yeah. So is it 3 and 2? What does that give us? Okay. And then V as the first letter. 1, 2, 3, 4, 5, 6, and E is the last letter. Now, if we have that, what have we got left? That. And so there's 6. And are there any double ups in this arrangement? 2 factorial. and 2 factorial, because we've got 2 e's and 2 r's, and this gives us 180. Okay, so probability 180 over 3360, and that simplifies down 356. Okay, yeah, we're just about done. Okay, last one. Okay, both the r's together, given that all three. Oh, okay, so this is conditional probability, hey. Okay, so let's do R, R, E, 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 S, V, D. So I've just got all of the letters that are similar together. So R's and E's together. This will be 5 factorial. Can we see that? 1, 2, 3, 4, 5. Okay, so it's 5 factorial. You happy with that, Pagoa? Yeah. And now, if it's given that all the 3's are together, so we want to do the E's and the R's are together, and then on the bottom we just want the probability of the E's being together. Okay, so this would be 1, 2, 3, 4, 5, 6, and then we've got the double ups of the R's. Okay, so it's going to be like 5 factorial over 6 factorial over 2 factorial, and I got 1/3 is my answer for that. All right, I guess we'll wrap it up there. I hope that's been helpful to you. I got a copy of the rest of the answers, which I'll leave down the back there for you to check in your spare time.